Welcome back to Ox Tools. I'm Tom. So what we got here is a mega batch of Meatloaf. And for those new viewers that don't really know what the Meatloaf format is, what this is kind of a mixed bag of engineering trivia, design, scientific instruments, tools, and gauges, all kinds of stuff. So we talk about a lot of different things. So typically no machine work in a Meatloaf. So if you're looking for pure machine work, go check out one of the other videos. And this is really about kind of unique items and engineering and scientific subjects. So let's check it out. What we have here, this is a small little, I would call this a dynamometer, and the reason being is it's for measuring, for measuring forces. What this one's for, and some folks out there may recognize this from the Western Electric days. I guess this was used, so I'm told. I didn't look it up. I was told by the guy that I got it from at an estate sale that this was used to check the spring force on relays for telephone switching stuff. And so it has a little flexible member here with a locating notch, and you would just pull, I guess, on the relay, and then there was some particular force that you were looking for, and then this has a little settable limit that so that you can come up and know that you're meeting the specification. And what this is here, I guess this is just a protective cover to keep it, to protect that flexure from getting snagged. Anyway, it's kind of a neat tool in that it illustrates that the steel, now that's just plain steel, well, it's actually spring steel, but it doesn't have to be spring steel, is very, very consistent in its elastic range, right? So if you have a known weight, okay, and a piece of steel, you can actually make your own scale that's actually very accurate. And we'll demonstrate this one. It's kind of cool. We'll go weigh this, and I have a scale, another scale. We'll weigh this on the scale, and we'll hang it, and we'll see if they agree. But what we're doing here is we're flexing this in the elastic range of the steel, right? And so all steels behave the same in the, pretty much the same in the, or very consistently, I should say, in the elastic range, right? That's why torque wrench, beam type torque wrenches work. These are all similar items, right? So this is functionally a beam type torque wrench, right? And which, if you needed to make one, you could make one. And here's how this one gets calibrated here is you can move that around a little bit and get on a different part of the arc. So that's how they can mass produce them and then calibrate them and then put them out in the field. So let's check it out and let's try it and see how good it is. And so this is calibrated the scale's calibrated in grams. So we'll go measure this little test weight here. All right. So here's my ancient top loading balance here. Or it's not a balance actually. It's a top loading scale. So let's set that on there. So 46.7 grams, so about 47 grams we'll call it, okay? All right, so let's go try our little dynamometer. I got this clamped in the vise here so that we can hold it kind of horizontal. And here's our little test weight here. Now we're going to read the scale upside down, unfortunately, but that's just the way it is. So let's put that on there. Let's see what we got. I'll make sure I got this out near the end here. And all right, hold still, you little bugger. Oh. It's bouncing pretty good. It's just shy of 50 grams, so You know, when you look at the scale resolution here, so what is it, 5-gram increments, right? That's pretty good, you know, for just a little kind of handheld jobber. A little point of reference here. So I mentioned that these are, it's 5 grams per division here. So a United States nickel is extremely close to 5 grams, and you know, depending on how worn they are. So one that's in pretty good condition is almost dead nuts 5 grams. So if you ever need a little example of kind of a test weight to make sure that your scale's reading right or whatever, throw a nickel on it. Should be dang close to 5 grams. But anyway, that's a cool little dynamometer and kind of a fun thing, and I like this kind of stuff, and so anyway, I bought this for, I don't know, 10 bucks or whatever it was, so I'm enjoying it. All right, this one here is, this is an eBay find here. And what it is it's an angle gauge block made by Starrett, or their Weber gauge division. And this one is a 45 degree, actually this isn't the functional side here, so really this is the bottom and this surface is what's really good. So these are Starrett system, they're actually used much like you'd use a sine plate, although they're ground and lapped to very high accuracy, a few arc seconds actually. So it's they're pretty darn good. Now this is one I bought a while back. I don't remember what I paid for this one. This one's Crowblocks. It's a chrome carbide. Starrett's, you know, kind of super durable, super hard material that they make gauge blocks and angle gauges and stuff like that out of it. Anyway, these are real handy around the shop, blocks that are accurately at a particular angle. This 15 degrees and 45, and the way Starrett system works here, let's see, let me give a little pointer here. And maybe you can see it, maybe you can't. There's a little plus and a little minus here, and same here, we got a plus and a minus. So depending on how you combine these, they add or subtract from the angle, okay? So with a full set, which I have a full set of these, and there's actually a 1 second block, you can get well, I can't remember the number of combinations. It's not a full 360 degrees, so it's 90 degrees in 1 arc second increment. So it's actually, you know, pretty finely divided. Now this one here, I paid 60 bucks for this, okay, which is a bargain. And you know, it's not in gauge block condition, but for shop use, it's pretty awesome, right? And no, it's got some crud on it. And I thought I cleaned this. Okay, anyway, it's in, you know, it's in pretty good shape. It had a little bit of staining I cleaned earlier, but it looks like I got something else on it, some bozo goo or something like that. I don't know. Anyway, they're just nice to have around the shop. These are shockingly expensive to buy from Starrett. If you need them, you know, they're really kind of calibration standards and things like that. They're really not shop blocks, but an example, Stan Zinkowski makes his little squares, right? This would be a good comparative standard to have around the shop for him, that he could compare his squares to and come back to some kind of good solid reference, right? So anyway, just a neat thing. So look them up on the Starrett Weber Gauge Division site, and they kind of explains how they're used and some of their advantages over sine bar methods. So these get combined with what's called a True Square too, and I have one of those that I'm going to show you here in a sec. But measuring angles in the shop is probably one of the trickiest operations, you know, measuring operations that you do, because it's rarely a clean setup, and you never quite have the right tool to get in there, or at least this is for me. I find that that's the case, and so having a lot of different ways to measure angles, if you do a lot of angle work, is pretty handy. So anyway, you know, trade secret there, that's one of my search words on eBay is Starrett Weber. And it kind of sometimes pops up with something like this. That's a buy it now, and you can pounce on it and get a good deal. So let's look at the True Square next. So this is a True Square, Weber Gauge Company, Cleveland, Ohio, and this is another eBay find. And this was even better. This was $23. Okay, and this is a what's called a True Square. And once again, it's not in absolutely pristine shape, but it's pretty damn good. And what I mean by totally pristine shape is I don't think I can get them to ring. They're just barely starting to ring. Let's see, not quite. So it's got a few little scratches and maybe it's got a little crud on there. But the idea is that you can ring these together. Now, when you have a True Square, okay, so now what you can do is you can combine these, and so you can actually go. If you have all the blocks, you can get a full 360 degrees of indexing there. So that's a True Square. It's about 25 millimeters thick, and I don't know, it's about 2 by inch and 5/8 or something like that. Anyway, the standard on these, this is a shop grade one here. I think it's 5 seconds. Within 5 seconds of 90 degrees on all four sides. And then also between one of the flat surfaces, and I can't remember which one, probably this one here because you can see the numbers on this side. This surface and this surface is also real accurate because you use them sometimes facing down like that. And if the bottom wasn't, if it wasn't perpendicular, it would pitch you at a weird angle like that. So once again, a little eBay find, and got caught by my little search word, Starrett Weber, and even had the little box and everything. I had to fix the box a little bit, but and then this is just kitchen wax paper, which is actually a nice liner for this kind of stuff. Oh, there it goes. Click. Okay, Starrett Weber gauge blocks, eBay. While we're on the subject of angle measuring, this is a new little set that I picked up at an estate sale. I'm gonna tell you a little bit more about this estate sale because it was a pretty interesting guy, and who's passed to the big shop in the sky, and he's worth mentioning, but I was contacted by his executor, and anyway, I was privileged to get a few pieces of his. Anyway, this is one of them. This is kind of an interesting set. I've seen these before. I've never played with one. It was made by Rover Industries. It's a micrometric tangent bar is what they call it. So I think this was a distributor here, Gordon Curley in Glendale. Anyway, what it is it's kind of a combined angle gauge block / sine bar kind of a thing. So it's kind of cool that way. So you can set angles to, I believe it's 5 minutes. Yeah, 5-minute resolution is what this has. And so this first step here is 0 to 5 degrees. So it's got a little, let's see. It's got a little scale in there. Hopefully you can see that down in there. And there's a little micrometer wheel that you can turn. So each turn of this is what, a half a degree. And half degree. And so we can go up to 5 degrees with this. This thing opens up. I'll just pull it. So it opens up to 5 degrees. And then what you can do is you can add additional blocks onto it. Okay, like so. And do 0 to 5 in that increment as well. And it has a little notch here, which is kind of cool. And you put a dowel pin in there, and that kind of sets the two together so that they don't come apart. So now, if we wanted to set 6 degrees, we would dial, or 6.5 degrees, we dial 1.5 degrees on that, and then we'd get the 5 degrees from that, and so on and so on, with the different combinations. Now, let's see. So you can go either way too, I think. So you can You can put them on the bottom as well. They'll go on the bottom. And let's see. Oops, I almost lost the pin there. So depending on which way you want to go here, some of them have 2 notches in it. Now I haven't checked to see how accurate these are. They look pretty good from here, and this is a no joke set, right? So I would expect it to be pretty good, at least better than 5 minutes of angle. And what's kind of interesting here is when you slacken the hand wheel there. So this is below, it's at 0 right now, and it's at below. And when you spin this up until it gets in contact, the index mark is perfect. So it's running that rim up, or the wheel up to the bottom of the hinge part, and it's ground really nicely, and the screws located really nicely. That this lands pretty perfectly on the index mark. So I was mildly impressed by that. So anyway, this is a mini micrometric angle set. So you may see that in some videos coming up, because this gives you, it's a nice size. It's small, so you can use it in the vise and in vise setups and stuff like that, where some other things, some angle blocks are just a little too big for that. So anyway, Rover Industries. I got a couple of books here. This is eBay, and this one here was from the Tom Pedersen estate. Let's look at this one first. This one's kind of interesting. This is mainly to do with kind of aircraft manufacturing jigs, and I've highlighted a couple of things of interest here. So there's the title, let's see. I forgot what the date was on this one here. Let's get that real quick here. 1947. Okay. So let's look at the first thing I got flagged here. I don't remember what it is here. This is pretty funny, actually. So this caught my attention here. So it's called beefing a jig. So you guys have all probably heard the term, let's beef that up, right? So maybe it got its roots in the aircraft industry when they had to stiffen or strengthen a jig or fixture. So anyway, there was a term, and it's in this little kind of dictionary here of terms and whatnot. So anyway, I thought that was pretty funny. So when I saw that, beefing a jig. So there's also some kind of I don't know, dated stuff in here that's kind of actually not politically correct, so I'll just leave it at that. So, this is something that I thought was kind of cool here. This is an alignment fixture, or alignment tool for aligning a jig or fixture. And what they're doing is, it's basically a plumb bob, but they're passing it through a small hole to align this in relation to the force of gravity. Okay. Now, what I thought was interesting is the name is called a bomb sight, and also this little guy down here, which is kind of neat, because what they've got is they've got a weight, and then in this cup they filled it with oil to kind of dampen the movement, so that it kind of doesn't vibrate so much and it settles out quicker. So kind of a nice setup there. Anyway, like I said, it caught my attention, so I share it with you guys. Kind of interesting design things. These guys, this comes up in this book a lot. They're using these Serobend to fill interfaces. So they align one member, and then this is a fixed member, and then they have some shimming to do in here, but it's not necessarily square with the world and whatnot. So you can fill an odd-shaped gap with Serobend, which is this low-temperature melting alloy. Actually, we used it the other day here in the shop on the sensitive feed wheel for the milling machine. So we made a casting of the spline so that we can measure it. Anyway, same material, and it can fill interfaces or fixture parts or grout parts very rapidly and securely. So anyway, this comes up in this book quite a bit actually, and so I flagged it to mention it. So let's see here, what else? This is probably the same thing here. Yeah, that's probably what what they're doing is they're grouting in, so they've aligned a forging die here, okay? So this is like a drop forging die here, and so they get it in the hammer, and then they do some aligning and checking and whatnot, and then they're happy with the alignment, right? So what they do is they're now pouring this serro bend in here to lock that die in so that under repeated hammerings, it's just not going to move around, and it's locked in securely. So I hope I didn't flag all the different applications here. Oh, this was kind of cool. I remember this now. They call this a Jeep here, and it's basically kind of a mobile workstation. Anyway, I just thought it was kind of cool. They had a name for it, and it's basically kind of a maintenance cart or a modification cart that can roll around the plant and do different jobs. Anyway, kind of cool. Let's see here. Yeah, that was one of the ones that. Oh, and I think this one was, I've got scraping on the brain right now, and I've been thinking about scraping and playing around with scraping quite a bit, and we're gonna do some scraping on some neat things. So there's some scraping stuff here. This is kind of a neat little thing here, this cool little tool here where you can, it's the right step for a ruler, right? So you can accurately align with the tick marks, but then you have a surface that is flush on the surface that you want to scribe on. So kind of a simple little project if you want to do something like that, and if you use a ruler a lot to do layout and stuff like that. Anyway, kind of cool. So that's I think that's about it for this one. It's a jig and tooling dictionary from 1947. All right, this is a catalog from the Harry M. Smith and Associates, and these guys were in Santa Clara, I don't know, quite a while ago. So I only found one date in this book, and it was 1974. So that's kind of the vintage of this. What's interesting about this is it's kind of filled with, it's got tools and tooling and whatnot, but it also has some, there's a good example right there. It's got some kind of fundamental stuff in it too. And secret of patience, do something else. Meanwhile, anyway, it's got some kind of good definitions, what flatness is and things like that. So it's kind of interspersed in the catalog here and there. There's a couple things I just wanted to bring up out of here. It's okay. Keep in mind this is 1974. It's got prices in it, which is always fun to look at, prices. So let's check some stuff out here. Okay, so we showed these a little while ago, True Square. So I have both of these actually, and I was wrong. The tool room grade here is accurate, plus or minus 1 second, and so. I'm not going to count the decimal place. It's about 4 millionths flatness, 6 millionths flatness. I'm reading upside down, so I can't read it. Anyway, these are made by Starrett Weber, and I was in error on the tolerances. I thought it was like 5 seconds, but it's actually 1 second. So the fancy pants ones over here, the laboratory master ones made out of crow blocks, quarter arc second, which is like nothing. That's beyond a gnat's what. So that was in there. Let's see what's the next one here that I had. Oh, this is oh yeah, okay, this is good here. Okay, so guys, here's a Ron repeatometer here, right? And we've talked about these off and on, and John Saunders has made a couple of these and gave me one, and I don't know who else he's given one to, but this is the one that killed me here. All right, check this down here. Here's the price. standard repeatometer for use with a 3/8 stem. So I'm thinking it doesn't come, this particular line item does not come with an indicator, $88. Now, if you want a MAR Super Mess indicator with it, now it's $120. That's like nutty. These things sell for like $1,500 on eBay. It's crazy. Case is $42. So those two numbers don't make any sense to me, right? So $88 for the unit, and then $42 for a case. So that doesn't quite, I don't know, that doesn't settle well with me, right? Half the cost of the whole thing is a case. That seems a little off. Anyway, Ron repeatometer, and this is a plancator here, right? Which is kind of it's comparing the surface plate to a known straight edge, and then you read the difference between the space here. These weren't as popular. These are really easy to use, and you can survey a plate really fast with these. That's why they're nice. But you need to set these kind of on a known, or a plate that's been collimated, or a known standard plate if you want to check flatness. You can check deviation without calibrating it on a flat surface, but you can't check flatness unless you calibrate it on a known flat. So let's see, what else we got here? I think I got one more in here. Oh, and this is another one here. Another kind of interesting data point. This is a Pratt & Whitney level, and so I've got a couple videos on restoring one of these, and my buddy Robin Renzetti did just a killer job resurfacing the bottom, and then doing more pattern scraping on the bottom for me. So it's just gorgeous. $140 in 1974. So these sell for, I don't know, $300 or $400 on eBay now for a nice, one that's in pretty good shape. So just kind of a data point. Anyway, Harry S. Smith catalog. I like, collecting old catalogs like this because, there's things that you didn't know you needed, right? In here, right? I see these on eBay every once in a while, these guys here. These are nice. You throw them in the vise and you can clamp on top of them. So that's kind of a nice feature there. This is a pile of kind of machinist literature from the estate of Tom Pedersen. There's a couple interesting pieces in here. We'll go through it. I got this one here because I actually have one of these. Somebody gave me one a long time ago, my friend Charlie. But this is the actual original brochure. What it is, it's kind of neat. It's a hardness tester, and it has a steel ball in it, and a little magnet at the top. So what you do is you tip it one way, and the ball goes to the top, and it's retained by a little magnet here. And then you place this firmly down on your sample, and you push this little button here at the top, and it releases the ball. And what you do is the ball bounces, and you read the rebound of the ball. And the harder the sample, the more rebound you get. Now, the sample needs to have a little bit of mass. You can't do it on an itty-bitty little piece. But it's actually surprisingly pretty good. And so anyway, I have one of these, and I played around with it and used it off and on, and but it was kind of cool to find the brochure that kind of goes with it, so that'll go in the case with that. So this is the one I really want to show you guys, which is kind of cool. So there's a couple Norton books, ABCs of internal grinding. These are all still, you can find these on eBay pretty easily here. Abrasive and grinding wheel selection. And these are just kind of like, I don't know, troubleshooting guides and kind of how-to guides and things like that. They're nice because they're small, and you can throw them in your toolbox and whatnot. ABCs of OD grinding, surface grinding. And then this is kind of the classic text on tool and cutter grinding. Somebody asked me about this recently, actually, and I said, find yourself a copy of this, and it has basically, all kinds of stuff on tool and cutter grinding here, and reliefs and grinds and wheel selection, etc., and all that. And this came from a company called Darling Abrasives, and I'm old enough to remember these guys here, and I actually went in there and I used to buy stuff from them a long time ago, and it was really cool because it was temperature controlled, just so the wheels sat at the proper humidity and temperature, and it was kind of a neat place. So anyway, down in San Francisco. So all right, so that's that. Diamond wheel stuff. Okay, this is cool. A cool little calculator here, and I don't know why I was really interested in this one. Probably because it included high-speed steel on it, which is, most of them are now just kind of basically carbide for carbide. Let's look at this thing here, because this is really cool. So this is, let's see, what's the date on this here? 1985, okay. So Tom had contacted the Hermann Schmidt company, and I guess he was inquiring about some Hermann Schmidt item, okay. And let's see here. This is the narrow wheel dresser. This is what they sell used for, oh well, actually, yeah, they're about that on eBay, I think, so. And then here's their catalog from back then, and it has prices in it, which is kind of cool. So this, they used to sell edge finders, and they were really nice edge finders too. And but you can't get those from them anymore. Let's see, side plate. Let's look at some of the prices here. So the vise, $340. This is $900 now, I think, something like that. I want to say. Magnetic V block, magnetic chuck. They used to sell 1, 2, 3 blocks, not anymore, with holes and without. Let's see. Oh, here's a squaring chuck. So is that the 6x6? Yeah, 6x6, $750. This is $1,200 now, I think, or $1,400 now. That's like over $2,000 now. And then here's some other goodies here. Let's that's all fine and dandy, but let's look at this, right? So this is the guy whose estate. This is Tom Pedersen. That address doesn't exist anymore, so it's not really an issue. But it's a letter to Mr. Pedersen, and it's actually signed by Mr. Hermann Schmidt, which I thought was kind of cool. So anyway, kind of neat. Back in '85 or whatever, he inquired, and Mr. Hermann Schmidt sent him a letter and signed it. So kind of neat. I just thought that was cool. So pretty nerdy, but it's still cool. So back in the day when you used to get a personal letter back, right? So. All right, so I know there's a bunch of guys out there like, gee, Tom, why don't you show us the damn thing, right? You talk about it. Okay, so here we go. So there it is. There's a little bugger right there, all right? And there's the ball, so you run it down. And we got two pieces of material here. This is heat-treated A2, which should be 58 to 62 Rockwell, somewhere in there. Actually, you know what? I don't remember the exact numbers. Robin got this heat treated for me, so I don't remember what that actually came up to. And then I have a piece of, this is 4140 commercially heat treated, so you can buy this as heat treated bar. I kind of sanded the face so it has a decent finish on it, and because the surface finish will affect the reading. Okay, so let's try it here. So let's try it on the A2 first here. All right, and let's make sure I'm in focus and you guys can read the scale here. All right. So what we're looking for is we're looking for the ball bounce, and I don't remember if you read the top of the ball or the bottom of the ball. What do you do? Section side, grinding spot, blah blah blah. Yeah, turn upside down. See the cap. Read the top of the ball, highest point. So this would be a good one for stopping the video, as the top of the ball bounces. Hopefully it's enough frames per second or whatever. So I'll hold the bottom here so it doesn't wiggle. Move that out of the way here. All right, let's try this here. See what we get. I got to see it too. So Or I want to try to see it at least. Let's see here. Okay, I missed that one. I missed that one. I was blinking or something, so let's see. Okay, I saw close to 60 on that. Okay, so let's try this other one. Once again, I didn't grind this, but which would be kind of optimal. But it's not going to matter. It's going to end up down near the bottom anyway. So here we go. 23 or something. Try that again. 20, 22, something like that. Anyway, that's kind of how that thing works. So it drops from a prescribed height, right? And the rebound, it rebounds more. So the highest elastic rebound is hard on hard, right? So, so the harder the better for rebound energy. Okay, now, of course, the brochure doesn't fit in the silly little box, right? So, great, what do I do with that now, huh? Okay.